What is up, folks? It is a couple hours later. I rotted in bed for a little bit. I'm not too proud of that. Had some lunch, made some food, sat with my family, did some car registration stuff. But now we're back. Okay. So I don't really remember where we left off, but if we go right over here, we will see that I'm currently computing metrics for... so basically what happened was that, like, when I would call data for... Do I even have it anywhere? Oh, yeah, I haven't checked on this in a while. That looks fine. 100% finished. Finally! Gotta let this bed cool down, and then I can finally see it, man. Jesus. But yeah, so when I would call data for... I don't have it here. Probably go over here, probably find it. Nozzle wiper releases. There you go, right over here. So this is for Georgia. It takes around 7 to 10 seconds to run. Oh shit, why is it taking so long? That's why. Did this thing die? Shit. It didn't die, but it sure ain't doing well. Okay, so yeah, my Switch suspended because I forgot to put it on charge. Oh no. Well, that's something I gotta fix. But basically what happened was that when I was calling data for, so this is Georgia, and Georgia would load around 7 to 10 seconds, but when I was calling data for Texas, it took well over a minute. And so what this program does right now is that it calls the raw data from the database and then computes metrics on the fly and then sends them to you. That was taking too long. So what I'm doing now is I'm doing all the heavy lifting right now. This is what this is. This is me pre-computing the metrics right now. So I wrote a little script that will pre-compute metrics.py all states months back. So it'll compute the metrics for all the states for 3 months of data. Character Marth, because shout out Marth. And yeah, so we'll see the outputs. Stored 141 players for Alaska. Compute metrics for Alabama. Stored 617 players for Alabama. That's Alaska, Alabama, Arkansas, Arizona, California, Colorado. So yeah, we can see that California has a lot of players. Heck yeah, shout out to California, most populous U.S. state. Florida 1780. Now Maryland, I'm curious about. Only 859. They just must have had some really big tournaments. Okay. 1081. So yeah, it looks like California and Texas are gonna have the most Smash players. That does track. They are the largest states in the United States. Yeah, we just finished Nebraska, so now we're on New Hampshire. And once I finish all of this, I can go ahead and send this new database file over to my Switch via local send. Hopefully it charges a little bit. And I just gotta turn off that screen so it charges faster. Ooh. Alright, so yeah, that thing is doing its thing. It is working. Well, it's charging. Let it live. I guess my services are down? I don't know. Tail scale status. Not status. Status. No, it's on. Okay. So that's good. I guess the API just shut down. I gotta enable that, but I guess I'll enable it once I'm like confident everything works well. Enable it as like a system service so that when the computer goes down, it auto starts back up, which is a really cool little feature that Linux makes pretty easy to do. Okie doke. So computing metrics as we speak. Switch is doing its thing as we speak. API is down, so that's not gonna work. What do we do now? So now I guess it's time to kind of work on the front end. There's a couple other back end problems that I had to fix with this. So one of the problems I was facing is that Massachusetts, Maryland, and Missouri all must have had really big tournaments recently, and when you have a really big tournament, the complexity of the query gets a little too high. So the maximum complexity that StartDG lets you query is 1,000 objects, and we were running up 1,500, 1,100, something around there for those 3 states. So I basically had to create a fallback which paginated the request a little bit more. So basically made smaller requests for the data until it completed. So we were able to get the data for Missouri, Maryland, and Massachusetts. Yeah, Missouri, Maryland, and Massachusetts. So those are the 3 that took a little bit of effort to get done, but created the fallback in the run report. So then I was able to successfully query the data for those 3 months, and now I can successfully run the pre-compute metrics for the last 3 months. So now I can definitively say that I have 3 months of Smash tournament data for the entire United States saved locally on my Switch, and then I also am computing metrics on them. It's taking a little bit longer than I thought it would. It must be like a coding thing, because this is it's not a beast of a PC, but it's a pretty good PC. I mean, you got a Ryzen 9 50-something X, you got RTX 3060. I mean, it's code, it's just number crunching. It really shouldn't be that long. Math just shouldn't be that long. I don't know. Maybe it's something I'm probably missing. Oh, wow. New Jersey has 1,000 players. That makes sense. New York might actually be smaller. But yeah. So we're doing all this. I guess what I need to do after this is start testing the API. And I'm thinking I should probably nuke the folder and re-download it from Git, because what's the issue? Why did I want to do that? Because I made a bunch of additions to some of the other stuff in this New York 246. No, Nevada. We're still doing New York. I made a bunch of additions to the program. I added the fallback to the run report. If I check the version control, I'll probably figure out what else I did. Added CLI flags. Can I just read this? Like, better than that? Alright, perfect. Added CLI flags to grab certain months. Yeah, so I added a way to segment the months that you grab, because currently it's like a rolling window where you grab a couple months worth of data from the day that you request it, couple months back. Now I have the ability to do segments of 1 month and choose how many months back. So like, I'll do a 1 month segment and I'll do it offset 2. So that means it won't be last month or the most recent month, but the month before that. So I did that to try and solve the problem originally, and that's where I realized that the problem wasn't that there was too much data, it was that some of the tournaments were too complex. So we got the pagination set up so that works. I probably don't need to update the repository on the Switch, but I'm going to anyways. LS, DB, no, not the DB. CD. Ooh, we got New York, right? Yeah. Let's look at that. New York, you have lots of players, almost 2,000. Who comes close? Florida is almost 2,000. Where's California? 2,500. Yeah, man. Florida, California. So we're going to nuke this repository. So we're going to remove force, or I don't know what, maybe recursive force, so that it doesn't ask me, because I don't know how to deal when it asks me. Smash DA. Hopefully that just works, but it probably won't. It will. Word. So if I do ls, nothing in there. Perfect. Now here I can do git clone, so I'm gonna go grab the repository from my other monitor. Perfect. So we do git clone. We have smash da. So this is gonna take a little while to set up. It's that is not meant to be a dev machine. I'll tell you that, man. I didn't realize that developing work was actually like, oh, it's a little bit of resource intensive. In my mind, that's a Nintendo Switch. It can play Breath of the Wild. It can play Tears of the Kingdom. In my mind, that should be able to make a Python environment without, like, you know, shitting itself. But no, it takes a little while. Nope. Slash DA, clear ls, perfect. So we're in the right directory. We want to python-m venv.venv. I'm pretty sure I have UV on here, but I don't know how to use it yet. I don't have UV on my Arch machine because the package just won't install for some reason. I don't know what the problem is, and you know what? It is what it is. Maybe it'll fix itself in about like a couple weeks. It's usually how it works with Arch. Okay, perfect. So now we have the venv, the virtual environment. So we could do source.venv/bin/activate. Oh, we're already in. So that was actually kind of fast. What did I want to do? I wanted to do the API, so I need to export some stuff first. Super T. I wanted to do export strategy API2 again. Perfect. And then we'll do that. And then export smash db path. I really need to put fish on here, man. Just make it a quality of life improvement. Or not fish. I like Zish. I like Oh My Zish. I don't like fish because some things don't work properly. Like to do the activate on a fish shell, you have to do activate.fish, and it's like, ew. I don't like that. Perfect. So now we're in. So now if I do clear and I do, am I running any random other terminals for some reason? Yeah, that's the one. Kava, we'll keep that. Spotify, we'll keep that. This is probably Bamboo Studio. Chromium, VS Code. Okay, that's what that is. And then fish and okay, we should be good. All right, we're in. This is the switch. This is my computer. We can just clear that out. The switch. We want to install requirements. Pip install requirements.txt. This might take a sec because we're on a little switch. What are we at right now? Pennsylvania has 1,000 people. Let's go. Guess that's what happens when you got Philadelphia and Pittsburgh. Yes, sir. If you couldn't tell, I like geography a little bit. All right. Tennessee, we're getting close. STUWX. So yeah, we got Wyoming, Utah. I think that's it. Wyoming and Utah are the last ones. It's probably like South Dakota. Well, no, STUV, WXYZ. Yeah. All right. Wyoming's gonna be the last one. Whew. Currently installing the requirements on the switch. We are trying to set up the this thing. So I do need to install the new API. Well, actually, no, I don't because I cloned it. So that's kind of useful. All right. Good shit, Git. And all I need to do is just this. All right, word. So we're waiting for that. Oh, the DB. I gotta update the DB on there. Yeah. All right. Alrighty, arborvitae. Let's open up another shell for. I guess I'll just. All I need is that to go down. Does this block it? No, you can still see it. Alright, perfect. SSH, I'll switch server at server. Nice. That switch is struggling, man. To, what is it, compile? I don't know. So it's, okay, it's gone. You know, let's do a quick little Neofetch, you know, just because it's just, you know, Nintendo Switch 2017. Pretty cool if you ask me. You know, pretty cool. Terminal. Blah, 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 blah. All right, Bash. Yeah, fuck Bash. Use this. Oh my god. Okay. What did I want to do here? Oh yeah. CD. I wanted to do documents. Clear LS. What do we got? God, dude, this thing is struggling. It's still working on that? Yeah, it's still working on that. So, CDDB, clear LS. We have the Smash database in here. I want this database, once this is done computing, I want this onto my Switch. So we'll work on that. Let's super T real quick roll here. I want to do an NCDU on, yeah, perfect. That's exactly what I want to do. Well, yeah, we can just do that. So yeah, we're coming up on 430 megabytes. Something that's a little bit unfortunate is that eventually when this is like production, I will probably move the database from my Switch to Supabase, and Supabase lets you put a 500 megabyte file free. So this will probably work for now for like a couple weeks / months, but once I get like one more month of data in there, like it's kind of cooked, you know. They're gonna make me like pay. But yeah, I guess I can start working on the front end. I just okay, this is done. Perfect. We want to remove -rf smash.db. This is really scary. I really don't want to do that yet. I just want to make another backup copy of the one that I have. So we'll close that. We'll go to workspace 3 and we'll do super F. We've got code repo smash.cache.g. That's the database file. If I do properties, probably just see the size here. Yeah, 440. Yeah. Okay. Tennessee, bro. What is going on in Tennessee? How many people they got in Tennessee? Not that many. Hold on. $7.2 million people. Yeah, well, it's actually more than I thought, I guess. No, yeah, Pennsylvania's like literally double. All right. Oh, fuck. Chrome. Fuck. And then Control-T. Perfect. OBS Studio, we're gonna look into that later. That's I'll get rid of this tab. What day is it today? November 16th? I guess it's time to, hold on, let me check my phone. Alright. Today is the 16th, indeed. I swear I thought I had a reminder set up. Post on LinkedIn tomorrow. Okay. So December 17th. Yeah, man. Trying to get a job. Gain something other than sales. Okay. This isn't done. Tennessee. Alright. So Tennessee was the last one. I guess Utah and Wyoming don't really have Smash tournaments. It's kind of hard to believe. Finishing Why is it 42 states? Okay. Run, Python. Let's do Python. Run report.py. Wyoming. This is taking a while. I guess 8 seconds is not that bad. So we got Wyoming. We have people for Wyoming, so why Python precompute metrics.py? Wyoming. Interesting. And it stated that it finished. Oh, Jesus, there's nobody in Wyoming. Good Lord. Finished processing for 42 states. Curious, where are states like Wyoming and Utah? They do have really small scenes, it seems. But it seems that they are real. So where are the 8 missing states for pre-computed metrics? Also got a question. What if I did run, oh, Python, God. Forgot, fucking VS Code. Python. Run report.py for, what if I did Puerto Rico? Does that work? It's looking like it's working. Hey! Hey? No, yeah, Brazil, Spain. This is weird. Mizkif. Mizkif is... Huh? Mizkif, American YouTuber. Yeah, what? Maybe I'm missing something. Supermajor.gg. Mizkif. No, oh, with a Z. There is a Spaniard Mizkif that shows up. Interesting. Someone else, I guess. What do? I guess it really is only U.S. only, motherfucker. God, it catches other countries, but the report requires U.S. I mean, I don't know. If someone asks, I'll like work for other states. I do want Japan. I do want Japanese stuff in there, man. So where are the 8 missing states for the pre-computed metrics? Yeah, let's just ask. Only iterate states that already exist in your local SQLite store. That comes to the list of the tournaments table. Take a application right now. Your cache only knows about what? Python run report. No. Python pre-compute metrics. Spec 3. Yeah, Wyoming. Yeah, let's try this. Yeah. Oh. That's the problem. Computing measures for Wyoming. Fuck, dude. Why didn't my earlier script work? Why is it only 42 states? What am I missing? It should not take this long to compute metrics for Wyoming. But I guess next order of action is figuring out what I'm missing. Okay. Or no. Could have used that. Obsidian. List of 2-letter state codes. Okay. Alabama, Arkansas. Yeah, West Virginia. I don't ever remember running West Virginia. I forgot that's a damn state. I guess AI forgot that too because we do have Wyoming now. Okay, so let's figure out what we're missing. Is there like an easier way to do this? Okay, perfect. This looks like a good list. Okay. Georgia, we have, so let's get rid of Georgia. Alabama, we have, so let's get rid of Alabama. Alaska, we have, so let's get rid of Alaska. We can try American Samoa. We have Arizona. We have Arizona, Arkansas. Yeah, we have Arkansas. We have Arizona. We have California as well. Yeah, California, Colorado, Connecticut. So we got all of these. We got Delaware as well. We do not have DC, so we can probably try adding that. Florida, Delaware. We have Guam. We do not have. We can try Guam. Hawaii. So Hawaii we have Idaho, Illinois, Indiana, Iowa, Kansas, Kentucky, Louisiana, Maine, Maryland, Massachusetts, Michigan, Minnesota, Mississippi, Missouri. We have all of these. We have Montana as well. What is going on? What are we missing? We supposedly have Montana. I don't really remember if we computed Montana anywhere. Let me see. This is Wyoming. Okay, yeah. We did do Montana. Okay, word. Montana. Nebraska. Okay. We have Montana. Where is this? Montana. Interesting. 43. Yeah, we are not everywhere. So we have Montana. We have Nebraska. We have Nevada. We have New Hampshire. We have New Jersey. We have New Mexico. We have New York. We have North Carolina. We have North Dakota. We have Ohio. We have Oklahoma. We have Oregon. We have it up above. We've got Pennsylvania. We've supposedly got Rhode Island. We've got South Carolina. We've got South Dakota and Tennessee. Interesting. So I'm missing Texas. That's weird. Where's Wyoming? Looks like we're missing Wyoming, even though we just did it. It's so weird. I don't understand. We'll do Wyoming again. Northern Mariana Islands, MP, Pennsylvania. Rhode Island we have, so let's get rid of Pennsylvania. I'm missing Texas. Where am I? Is it up above? No, I'm missing Texas. Word, okay. I'm missing Vermont. I'm missing Virginia. I'm missing the Virgin Islands. I'm missing Washington. Dude, I'm missing a lot of states. What is going on? West Virginia, Wisconsin, Wyoming. Okay. Python, run report. Puerto Rico, let's do, okay, let's copy this. Can I run multiple states at once? I don't think so. Okay, wait, let's do, Utah. Let's just focus on the American states for now, dude. I love you, all you other folks. I'm broken inside, alright? Cut me some slack. Okay. So we have Utah. We have, what's back 3? Let's do Texas. Dude, I don't have Texas. I've done it before, yeah, apparently. I must have deleted the database. And then Virginia or Vermont. And then West Virginia. And then Wisconsin. So that's 1, 2, 3, 4, 5, 6. We're missing 1. Texas, Utah, fuck, dude. Whatever. I'm just gonna run them. Interesting. Okay. Yep, I expected that. Alright, that one's running. Oh, because these are new shells. Okay. And then we have to write a pre-compute. Several. Curious if running Python pre-compute metrics.py state, let's just do TX UT VT VA VI WA WV WI. I must be missing Wisconsin, right? No, that's Wisconsin. West Virginia. I'm missing Washington. Okay. Yeah, let's put Washington as well. Washington, Wisconsin. Do a bunch of separate flags, or should I make a separate script? How should I go about this? God, it's hot in here. So it's separate flags. Okay. The parser uses action append, so you can pass as many flags as you need in a single call. Oh, I could just run all states. It's true. I'll probably do that, right? So, okay. I'm running a bunch. These are all going to take a while. Okay. Man, this is so difficile. Perfect. We're at 22%. Not bad. I've sorted out most of the back-end issues. Right now it's finishing up my database and then testing some back-end shenanigans. If everything works, then we can finally move on to building the front end. Once we get the front end down, finally move on to building the front end. Once we get that down, I can work on deployment. But made a lot of progress. I've managed to get my devices talking to the switch for the database purposes. Yeah. I managed to get my device talking to the switch for the database purposes. Now it's plugging in that feature into the front end. Oh, that's pretty cool how that works. Okay. Okay. Let's see here. I want to make a front end. Okay. For this program. Ways to do that earlier. I actually want to make this program a web app accessible. Dude, I gotta turn off that heater. Good God. It's hot. And I gotta grab some water. Be right back. arborvitae. Okay, so I just got water. I ran some laps around the kitchen. It looks like we got Vermont, which has 2 people in it. Good for them. Let's see. We're still working on Virginia. Oh, what? Read timeout. That's not good. Hopefully it doesn't keep happening. God, this is really fucking annoying. Okay. So he timed out. Let's just start closing these out. We got Vermont. We're working on Texas. We're working on Utah. We timed out on West Virginia's. Okay, that's the one we timed out on. We're working on Wisconsin. We're working on Washington. Virginia, Texas, Utah, Washington, Wisconsin. Okay. And we do need to run this again. But I'll probably wait till some of them finish before I do that again. Because it's probably rate limiting me because I'm, asking for so many at once. This is why that script was useful, because I did it one at a time. I actually want to make this accessible by the internet at large. Now, we discussed this earlier, and I asked if I should fork it, but you said no. Then we talked about some suggestions that we can make this work. The thing is, people might download this program off of Git and use it themselves or fork it themselves. I want the core functionality to work. I don't want to make it so that the Jupyter Notebook, what I use currently for visualization, calls my API on versions that other people downloaded. They can work with their own data locally. Now, I do want to do this. I want to build a front end. I figured the easiest way to go about this that will look relatively nice is Streamlit. It seems that it has a dark mode of some kind and that it works in Markdown, which are great. Now, I don't know how to turn my notebook into a stream. At front end, but I do believe that is the route I want to go. Curious. How large are the files that GitHub lets you upload? How large are the files that GitHub lets you upload? Interesting. Free plans, typically include 1 gigabyte of large file storage and bandwidth, which resets monthly. Paid plans offer large. Interesting. Okay. Yeah. Curious. How should we go about this? And how do we make it so that the eventual front end talks to the API? In this case, I guess I am okay with forcing that behavior on Streamlit. Our cleaner, decoupled solutions, I would like to explore those. A straightforward AdaWeb front end is to treat your existing Python package as the engine and build a thin Streamlit app that orchestrates it. Streamlit runs as a normal Python process, so it can either talk directly to your existing modules for local users or call a hosted API for your own deployment. You can support both. Sketch. Keep your current CLI. Whew. Okay. Keep your current CLI API code untouched. Expose the analysis function in a module called smash_ccanalysis.run. Then return plain Python results, data frames, or dicts. Create a Streamlit app.py or package that imports those functions when useLocalEngine true and displays the outputs. When useLocalEngine false, the same Streamlit widgets hit your hosted REST API through requests. Use the environment variables or Streamlit's secrets.toml to toggle between the modes and configure base URL/keys. This way, folks who pip install or clone the repo can run Streamlit up, and have everything stay local without hitting your infrastructure. That's pretty cool. Okay. For your hosted version, the Streamlit app can live on Streamlit Cloud/virtual machine, configured to call your Fast API backend, lock the backend behind authentication if needed. This keeps the front end decoupled. Streamlit is just another client of the public API, but it can fall back to local function calls when network access isn't allowed. Suggest next steps. 1. Identify the notebook workflows that map to pages/sections in the Streamlit app. 2. Extract the core logic into reusable functions/modules if needed. 3. Scaffold Streamlit app.py with basic navigation and one end-to-end example. Add configuration toggles for local versus backed mode, API back mode. Oh, what am I doing? Oh, what am I doing? Wow, dude. Is it just that freaking behind? It's like a good 30 seconds behind or some shit. I guess, I don't know, that's weird. Alright, it's like only 15. Okay, then let's move on to the next steps. Okay. Everything's still saying Python, so everything's still running. Yeah, bam. Should take a while. Alright, word. Okay, let's move on to next steps. What are my next steps? Identify the notebook workflows that map to pages/sections of the Streamlit apps. I don't know what that means. Identify the workflows that map to section to I'm not entirely sure, but I have a rough idea as how I want things to work. I guess just to try to understand what makes a good Streamlit app. Oh yeah. YouTube.com. Streamlit app. This is what I watched earlier. This guy's video is pretty good.
Welcome to this video where we're going to take a look at the Streamlit library in Python and see how you can use that to rapidly build a data-driven application. In this video, we'll take a look at how to install Streamlit and then also take a look at some of the basic features to help you get started quickly. We'll then take a look at how to create a simple mortgage calculator app so that you can see how all of the pieces will fit together. This is the app we're going to create. It's going to be a fully functional web app with a UI that looks really modern and clean. And you can also have input elements.
Dog. That shit does not look really modern and clean. Get some colors in there.
For your users.
It does look clean though, because Jupyter Notebook does not look clean.
To interact with. For example, things like text fields and buttons. We'll also take a quick look at how to deploy this to Streamlit Cloud for free. This will make your app accessible to the rest of the world.
Really? What is Streamlit Cloud? Really? Wow, that's pretty cool. If I build my front end in Streamlit, I can just one-click deploy to the Streamlit Cloud. So if I build a front end for my Python application that calls an API from my database, would that all work on Streamlit Cloud? Setting, environment, variables and stuff. Or would I have to go to the secrets.toml file route? I really love the color of this cursor. I love that it changes, dude. I wish I could just do that normally. I mean, I probably can't. Oh, I use Cosmic. Ah! Can I change the cursor on Cosmic? Can I change the cursor on Cosmic? Interesting. So apparently you can. It's really simple. All you need to do is occur to the theme you'd like to use. First, download a theme you're choosing. For my example, I'll be using Babata Ghost. Be sure to replace it with instances of the theme I'm using. After that, extract and move the theme to Unix system resource, share icons. This will allow it to be used by system services like Cosmic Reader. From here, you're going to add the two variables to etc. environment. These so the theme is consistent across Cosmic itself. If field quarter being way too large, have remember allocation. After letting me get to alternative experts of the theme, this is alright, pretty complicated, but this looks possible. Awesome. Awesome. Okay. Community Cloud free. The Community Cloud tier is free. You can deploy an unlimited number of public apps. You also get one free private app where your code remains hidden from the public, but the app can still be shared. Interesting. There are paid enterprise-grade options, such as through Snowflake for more demanding corporate needs like unlimited private apps and advanced security features. The deployment process, one-click deploy. The one-click deploy process is straightforward and fast. Push to GitHub. Your app's code and a requirements.txt file listing Python dependencies must be in a GitHub repository. Link and deploy. From your Streamlit Cloud workspace, you can link the GitHub repository, select the main Python file, and click deploy. Automatic, so I can do a Streamlit app. Oh, this is fucking sick. Automatic updates. Once deployed, any feature code you wish to push to that GitHub branch will trigger an automatic update of your live app, calling an API and setting variables. Your Python application that calls an API from the database will work perfectly, but you will need to handle sensitive information like API keys and database credentials securely. The recommended route, Streamlit.secrets. The Streamlit Cloud provides a secure interface for managing sensitive data. Instead of using environment variables directly in your code, you can use the built-in st.secrets management. How it works: you add your secrets to the secrets field in the app settings on the Streamlit Cloud interface using the TOML format, e.g. db. Oh god, I don't know how to use TOML, but apparently it's really good. Example, db username equals my user and API key equals my key. Within your Python code, you access these scripts using st.secrets, db username, or... Oh! Okay, that makes sense. So this becomes... Okay. Streamlit automatically makes these available as environment variables to your running app. So libraries that look for environment variables, example, some database connect... Oh! Really? So I don't have to like change anything in my code? So I can do start.gg underscore API underscore token equals, and then if I do the token, it'll just work. Interesting. Streamlit automatically make, okay, yeah. So in summary, you can absolutely build and deploy your full application, front end, and API calls for free in Streamlit Community Cloud using the one-click deployment from GitHub, provided you manage your sensitive credentials via the secure st.secrets manager. Interesting. Okay. So is this secrets manager a separate file that I import? Is it part of the one-click deploy? Assume I use environment variables like start gg API token equals. Would the TOML look like that? Because you said maybe something like start gg API token equals period. The secret manager is not a file you commit to GitHub. For deployment to Streamlit Cloud, you manage your secrets to the app settings interface. Streamlit then exposes these secrets as both an accessible st.secrets dictionary and as a standard environment variables in the deployed apps container. A local file named streamlit/secrets.toml. Stored securely on the Streamlit cloud server. Okay. No, you should add to your git.ignore. Okay, so you do. Okay. No, you're not. Okay. Edit the secrets text in the area app settings in the Streamlit cloud workspace. This is very confusing. Okay. Streamlit cloud workspace. Streamlit community cloud. Streamlit.io. Join community cloud. Continue to sign in. You may have my information. Zero con primary email. What's your functional area? Sales? Create your first app now. Fuck. Yeah, I don't have that. Okay. So I need to stream that app.py. Okay, cool. Cool. Alright. How are we doing on the... We're still on Pythons, though. Still working on Washington, still working on Wisconsin, still working on Virginia, still working on Texas. And still working on Utah, baby. Fuck, dude. Fucking tired. 31. Oh, let me go check this thing out. Hold on, guys. Please work. Oh, there's a support. Okay. What color is this? Please. Please just work. Do not cause me any problems. No way. ladies and gentlemen. It took 24 hours, but we now have a Monopoly Deal card holder. Now, if you choose to print this thing, do not do 2 colors. Literally every single layer in this thing has 2 colors. So you're going to be switching and discarding filament every layer. It's going to put on so much extra time and it's going to waste a lot. But it does look a little cool, so that's cool. Mishabaji. Oh, I gotta go clean the. God damn, still streaming? Alas. My mom needed a thingamabob. She needed like a puck. Zin? Are you kidding? That's funny. How do I search? Where did I save it? Did I text it to myself? Maybe I put it on Discord. I did. This thing, perfect. 70 by 30 probably is fine. You're a fucking bitch, dude. Fine, I'll log in. It opens up another Bamboo Studio? Yeah. That's fucking dumb. Well, whatever. I'll hold on to that for now. Okay. 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 How do I change the filament? By layer, god dude, how do I strength, support others, quality, advance? I just want to choose the filament, bruh. like what I'm seeing. The fuck is all that? What the fuck is all that? Alright, whatever. Generic PLA, generic PLA, basic PLA, basic. I don't even think I have a diameter. Well, I don't even know what it is. I should really learn. How do I select what PLA? Oh, it started freezing. Okay. Okay. Oh, that's why. Just gonna do it for my phone because I'm not understanding. Is now working. Good. What are we looking like? We're still calling the API? Dude, what the fuck? Should not take that long for some of these states like fucking Wisconsin or Utah. Okay. Let's get back on this front end. Oh, dude, I'm tired. Perfect. I'm not into. Okay. Let's move on to the next step. So I guess we should start identifying the workflows that map to pages/sections in the Streamlit app. I'm not entirely sure, but I have a rough idea as to how I want things to work. My idea boils down to this. Right now, I use the Jupyter Lab to show the value of the visualizer. I generally call the show the value of the visualizer. I generally call okay, I got another question actually. I should probably ask question. Does Streamlit support landing pages and whatnot? Or is it just one page with the app, so to speak? In that case, suppose I deployed to Streamlit Cloud. Would it be worth it to build a front end in, say, Webflow, and then embed the app somewhere in there? Or is it better to just build the whole thing in Streamlit? Does support multi-page applications, which can function as a simple website, different sections. In an app page, you have two main options for deployment. Build the entire site in Streamlit. You said I have two and you only gave me one. You place all your different files in Python within a folder, and pages in your repository. The main file app.py or home.py acts as the home page. As the Streamlit automatically generates a sidebar navigation menu for you. Pros: extremely fast to develop as well in Python, seamless one-click deployment to Streamlit Cloud, no complex integrations to manage. Limited design customization to follow Streamlit style, not designed for complex professional landing pages that need deep SEO optimization or specific branding control. I think I'll just focus on just the app. Okay. Okay, so if I wanted to build a front end in Webflow, would I be able to embed the Streamlit app within a page? That way, would it integrate seamlessly? You can embed a Streamlit app within a Webflow page using iframe element. This approach allows you to build a traditional landing page with Webflow while seamlessly integrating the interactive data-driven functionality of your Python-based Streamlit application as a component within that page. Embedding in Webflow, how it works. Deploy your Streamlit app to Streamlit Cloud. It must be a public app for this to work easily. You can get a unique URL, your app, name.streamlit.app. Okay. Add an embed element in your Webflow Designer where you want the app to appear. Use an iframe code snippet in the Webflow embed editor, pointing the source attribute to your Streamlit app's URL. Example iframe code. It's just not working. Like I said, I had two options and proceeded only about one of them. It said that here is some example code, and then nothing, no code.
via a URL. But first, what is Streamlit exactly? Streamlit describes itself as an open source Python library that makes it easy to create and share beautiful custom web apps for machine learning and data science. You can install it with pip using this command. Once you have it installed, just go into a new folder and create a Python file. Add this line of code to it. Now to run the file, just use this command except with the name of your file. Let's go to our code editor and try that out. So here I have my hello world message, and my file is called hello.py, so I'm going to run that. After you run that, your browser window should pop open with your Streamlit app. It's going to be a very plain app for now, but you should see your hello world message being printed to the app. How Streamlit works is that it will evaluate your file from top to bottom and render each thing. in the order that they appear. If you put something underneath this line, for example, let's put a text input element, then when we go back to our app and run it again, there's a button here to rerun it or always rerun it, you'll see that this element appears below that hello world message because we had put this first. And this new element I just added is actually a text input field for my app, so users can type anything they want into this. Streamlit actually provides you a lot of different input elements you can use, and this is one of them. And if you have an input element like this, it will actually return the value that the user puts in. That means you can also capture that return value into a variable like this x here, and then use that in your app. Once you've stored that value, you can use it just like any other variable. And if the user changes something in the input, the app will rerun the entire script to generate the page if it detects that something has changed. So let's go back to our code editor and give that a try. Okay, so I've added my variable here, and I'm printing out whatever the user types into the text field here. So whatever value I decide to put in here, I can just type it in and press enter. And you'll see that it stores the variable and it can use it in a later part of the app. You can create things like buttons, sliders, and drop-downs as well. Pretty much anything you can expect to find in an interactive app. Now, something I personally really like about Streamlit is that it also supports Markdown formatting by default. So you can do things like titles and code blocks really easily. Just use normal Markdown formatting in your string and Streamlit will render it for you. This includes things like italics, bold settings, even headers, bullet points, and code blocks. If you want to see a full list of all the different components available on Streamlit, then head over to the official documentation and go to the API References tab. And if you scroll down, you'll see a bunch of text elements, data elements, charting elements, and input elements, and so on. So there's actually quite a lot of stuff, and you can go here to check it all out. At this point, you might have noticed that Streamlit is geared quite heavily towards working with data. So let's go ahead and see what that experience looks like. If you have a CSV file that you want to use as part of your app, then this is how you can do it.
Hmm.
All you have to do is import the file with pandas, and then you can simply use the Streamlit write method to display that data inside your app. Let's go back to our app and try that out. Here I have a CSV file called movies.csv, which I downloaded from Kaggle, and it's basically just a file of different movies available on Netflix. Here we're just going to load the file as a pandas data frame, and we're just going to draw that data with Streamlit. If we go back to our app and refresh it, you'll see that we get this really nice table here, and you can explore the data, you can even edit certain fields of the data, and you can even sort the columns. So natively, it's got really good view and really good UI for working with CSV data, or most other common types of data as well. You can also show your data in a graph. So in this example, I'm going to generate a bunch of random data, and I can display it in a bar chart or a line chart. Let's go back to our app and try that out. And here, if I refresh the page, I get the charts that I created with a bunch of random values being plotted. And these charts are really interactive as well. You can zoom in.
That's really cool. Pretty cool. Nice! This is the Streamlit Assistant. This will be useful. Nice. Okay, cool. That's cool. Install. That's cool. I can't read. It's too far. Macau. Okay. Lord, that is slow. Okay. And it kind of works. Okay. Oh, okay. That's pretty cool. Okay, that's a cool app. This is it. This is well designed. I've noticed none of these have pages. They're all just one thing. Best stock Google, worst stock Meta. Oh, word. Up 95%. Worst stock. Should have invested into Google. Fuck. This is well done. This looks good.
You can zoom out, and you can also mouse over these elements to see what their values are. Once again, if you want to see all the available options, then check out the API references page on the official Streamlit documentation. If your app starts to get a little bit too big to fit on a single page, Streamlit also gives you a really easy way to create multi-page applications. All you have to do is just structure the project so that you have a directory named Pages, and then with each page is a file inside that directory. Now Streamlit uses the naming convention and the structure of your directory to figure out how to organize its pages. So that means you do have to name the folder exactly like this. And then you can tell it which order to display the pages in by prefixing it with a number. The page itself won't have the number prefix when it appears in your app. Let's go back to our code editor and try that as well. Here I still have my main file, but I've created this pages directory and I've put two new files in there. So one is going to be a profile page and then it's going to be a dashboard page. And once I rerun the app, this is what it's going to look like. So I'm going to have this sidebar here that I can expand, and it's going to have a list of all my pages, and I can click on them to go to that page. So here's my profile page, and then here's my dashboard page. So that's how you can build multi-page apps using Streamlit. Now I think this is pretty cool, but it's still quite limited. You can build something too complex with this. For example, if you wanted nested pages or dynamic pages, it's not really easy to do that right now. But it's good enough for when you just have a handful of different pages you want to use in your app. What if you wanted to link to an external site or even to a different page on your own site? Well, Streamlit has this input widget called a link button. It's just like any of the other input components we saw earlier, and here's how you can use them. It just takes a label, which is what the button will say, and a URL. And if you really wanted to do a dynamic page or a page that loads in some arbitrary data, you could potentially use something like query parameters with your URL as well. It's a little bit hacky, but it works for that. But again, as I said earlier, it's not a great navigation experience. this link here will always open in a new window. So if you need better support for app navigation, you might want to look into something like a proper web framework, like Flask or Django instead. Where Streamlit really does shine is building simpler apps that are interactive and heavily focused on working with data or machine learning. So let's put all of that together and see how to build a functioning loan repayments calculator using all of this. Now, I'm going to be stepping through this code quite quickly, but if you want to slow down and take a closer look, then check the link in the comments for the GitHub repository with all of the source code. Let's go back to our code editor now and walk through this step by step. So first, I'm going to have a bunch of imports, and then I'm going to create the title for the app, which is going to be a mortgage repayments calculator. Next, I'm going to create a couple of input fields for things like home value, deposit, and interest rate. So these are the inputs from the user that I'll need to calculate the repayments. And you can use things like this to set a default value or minimum, maximum values. And here, if I want my elements to not display in a single column, I can also use this column component to split it up into two different columns. So I'll have each of these elements render in two different columns side by side. In the next step, it's just a bit of math. There's nothing unique to Streamlit here. This is just mortgage repayment calculator formula. So just go ahead and copy that to get the right value for the monthly repayment. Next, we're going to want to display the repayments. So I want to use this metric element because it will make the numbers kind of pop out and a little bit bigger than if I just wrote it as plain text. So I'm going to use 3 different metric elements. I'm going to put them.
I see. Interesting, okay. Christ, that's a lot. This is pretty good.
All on the same row by creating these columns, and I'm going to show the monthly repayments, total repayments, and total interest. So this is where I'm displaying output to the user. Finally, I'm going to do a bit of math to calculate the payment schedule over the loan term. So here I really want a graph of how much remaining balance is left on my principal. And once I have that information, I can put it into a Pandas data frame, and then I can plot a line chart to show that remaining balance declining. Now I'll pop open my terminal and run this mortgage calculator app here. Cool, and you see that it loads and it's got all my default values, and here is my payment schedule calculated for me over 30 years. And if I change the home value, you should see all of these things change too. For example, if I go from a $500,000 home to a $700,000 home, you see that this is how much the monthly repayments would be. I can also play with the interest rates to see how that affects the repayment schedule. So kind of just to recap on what we built, when we write an app with Streamlit, Streamlit will evaluate it from top to bottom. So you can see that everything we write will be rendered in the order they appear in. And things like input elements will return the value that the user puts into that element. So anytime I update one of these, this value can change. And because it renders from top to bottom, anywhere I decide to use one of these variables will get changed or affected by that as well. So if you can see here, I can change this number to 4, for example. And then if I press enter, that whole app gets re-rendered from this point onwards, and it's using this as a calculation instead. Finally, I have all the data I've calculated, and I want to display them in the right way. So you can see these metric elements being displayed in the columns here, and the numbers are nice and big because that's what I want my user to pay attention to. And I also have a graph showing the payment schedule. And if a line graph is not the right type of graph for you, then again, in the Streamlit documentation, there's a bunch of other different graphing widgets you can use for your data. Now let's take a look at how you can deploy this. Streamlit apps are really easy to deploy. You can use Streamlit Cloud to deploy for free if you're happy with your app to be publicly visible. First, you need to make sure that your app is published to GitHub, because that's where Streamlit is going to read the source code and then deploy it from. And if you have any Python dependencies, then make sure to put them all into your requirements text file as well. When Streamlit tries to deploy your app, it's going to run pip install on this requirements text file. So if you needed to install anything, make sure it's there. Once all of those things are in place, go back to your local version of the app and then click this deploy button in the top corner. And here you can choose to deploy to Streamlit Community Cloud for free. Fill up all of this stuff. Here you can paste your GitHub URL, select your branch, and then select the file that you want to deploy as your app. Once you're done with that, hit deploy. Now this could take quite a while the first time, but if you want to check on the status, then you can expand the tab to the bottom right, and you'll see the status of your app being installed and deploying. And after it's done, you'll have this app fully deployed and you can interact with it. And you also have a URL that you can share with your users, and they'll be able to use this hosted version of the app right away. Alternatively, if you don't want to do it this way, you can deploy it as a Docker image as well. You can deploy this to any traditional cloud provider, for example, like AWS. But that's out of scope for this video, so if you're interested to see how to do that, then please let me know. So now we've covered the basics of Streamlit, built a simple app with it, and deployed it to the cloud. This library is great for building data-driven applications where you want your users to be able to see or have simple interactions with your data. It's also really good for building things like a simple AI chatbot or an AI assistant. By the way, if you want to learn how to use AI to chat with your own files and documents, then also check out my previous tutorial where you'll learn how to do exactly that using LangChain and Python.
All right, text is finished. Let's go, boy. All right, team. I'm headed out, dude. I'm fucking tired. It is getting hard.